All right. Fundamental theorem of calculus, the weird version. Okay, the weird version. Here we have h of x is equal to the integral from 4 to x of cosine of e of t dt, but you have to find h prime. Well, what do we do with this? What do we do with this? What do we do with this? Let's step back actually and try an easier problem before we do this problem. Okay? Sometimes mathematicians get a hard problem. We're like, you know what? Let me try an easier problem and see if I can figure it out. Okay? What if I just had the following problem? From 4 to x, let's call this, let's call it h of x, sure, of just cosine of t dt. Okay. I look at this and I'm like, oh, so I need to anti-derive, plug in the limits, and I need to derive it. Okay. If I anti-derive, what's the antiderivative of cosine? Sine, yes. So this would be sine. I'm going to plug in my top limit, x. Then plug in my bottom limit, 4. Okay. So that's h of x. If I want to find h prime of x, I have to derive it, don't I? H prime of x. Okay, what's the derivative of sine? It's cosine, right? It's cosine. Okay, cosine of x. And if I do the chain rule, derivative of x is just 1, right? And then here, the sine of 4, well, that's just some number. That's some constant, isn't it? That's some decimal. And the derivative of that's just going to be 0, right? Now, what we could do, though, is we could say, okay, fine, minus the cosine of 4. But then when I do the chain rule, what's the derivative of 4? It's 0. So, yeah, it just goes away. Minus 0. So h prime of x is cosine of x. H of x is this. H prime is cosine. That's just the original function, isn't it? So that's an easier version of this. Let's try it with this. What is the antiderivative of cosine of e to the t dt? Anybody know? Anybody? Because I don't know. I don't know. I don't know. No clue. So what am I going to do? I'm going to call this f prime of t. That's that function. Okay? So if I'm doing h of x, what's the antiderivative of f prime? It's just f, isn't it? So this is equal to this whole thing. It's going to be equal to the antiderivative of that. I don't know what it is, but I'm just going to call it f. F of, I'm going to plug in my limits, x minus f of 4. Okay. Now I have to find h prime. So I'm going to derive this. H prime of x. Okay, what's the derivative of f? Easy question. F prime, yeah, absolutely. F prime of x. Then I got to do the chain rule, right? Derivative of x is just 1, right? And then the derivative of f would be f prime of 4. But then I have to take the derivative of what's on the inside. Derivative of 4 is 0, right? Which makes sense. F of 4 would just be some constant. We don't know what it is. It's essentially the plus c, okay? And derivative of c is nothing. So h prime of x is equal to f prime of x. This was f prime of x, wasn't it? Well, f prime of t, but now we're using x's. No problem. So what is this? H prime is equal to the cosine of e to the x. Ooh. And this should make sense because it's telling us, we know if I have to anti-derive something and then I have to derive it, I should end up right back where I started, right? If you have to square something and immediately square root it, you should end up back where you started. And that's what's happening here. You anti-derive it, then derive it. Right back where you started. Now it does get, here's the weird ones. Here are the weird ones, okay? What happens when it's not just a nice cute little x? Oh, it's just a cute little x right there. What happens when it's 6x squared? Okay. I'm gonna go through my thought process. Here's how I do it. I always say this, I don't know what the antiderivative of this is. So what am I gonna do? I'm just gonna call this whole thing is f prime of t. F prime of t is equal to the square root of tangent of 2 raised to the t. I don't know how to anti-derive that. But that's okay. I'm just going to call it f prime because now I'm going to rewrite this 0 to 6x squared f prime of t dt. So now we can use the fundamental theorem of calculus. What's the antiderivative of f prime? It's just f. F of 6x squared minus f of 0. Then I'm going to derive this function. G prime of x is equal, okay, what's the derivative of f? It's f prime. F prime of 6x squared, but because it's not just an x on the inside, we have to use the chain rule, don't we? Got to use the chain rule. Okay, so I'm going to derive this. What's the root of 6x squared? 12x minus f prime of 0. Well, I know that's just going to be a constant, right? I mean, it'd be f prime of 0, chain rule times 0. Okay, fine. Or you can just say, that's a constant. So it's really just 0. And so, g prime of x, what's that going to be? Well, it's f prime, which was this thing, right? But instead of t, everywhere there's a t, we have to put in what instead? 6x squared. So it is the square root of the tangent of 2 raised to the, instead of t, we put 6x squared all times 12x. Okay, pause, think about it in your own words for just a moment. Think about it just for a moment. Process what you're doing, process what's happening here. I do a lot of steps in here. Sometimes people are like, yeah, I don't, that's a lot of extra work. How would you summarize it? What would you do? How did I go from here to here? Okay. So find someone nearby you, talk it out, explain what's happening in your own words. And I explain like, hey, if I can't remember all this substitution going on, then just do this. Okay. Take about 30 seconds, 45 seconds, and talk to someone nearby you. Go.
Yeah, like, so what I did, I plugged in F prime to 0 plus 1. But the issue is.
Yeah, yeah. Yep. So you can look at it as this. So go from here to here. Anti-driving is driving. I'm just going to go like the same thing except that they get the two. Okay. Molly, how did you describe it? So take the top one. So this. Plug it in. Oh, you see the top limit. Okay, top limit. Plug it in for t, and then what? Okay, yeah. Yep. So 6x squared. We just plugged in for the t, and then we had to do that because of the chain rule. Okay. Carmen, how do you describe it?
That was basically what I understood. Is that I added the minus 0.
Okay. Yeah.
But I could do that.
Mm-hmm. Okay. So, question. Yes. You stole my thunder. I'm totally going to do that next. Okay. So what if Mr. Kuhne was a jerk and said from 4x to 6x squared? Does that change things? It kind of does, right? It's no longer just f of 6x squared minus f of 0. Now it's minus f of 4x, right? So what would it be now? So we're deriving this. Derivative of f is going to be f prime, right? F prime of 4x what do we still need though? Times 4, yes. So it would be this whole thing minus square root of tangent of 2 to the 4x times 4. So yes, that can totally happen. What if Mr. Kuhne was a jerk and made this one up here x to 4? how would that change the top one? It would make it negative, yes. Why? You're correct. Okay. It switches the limits. 4 to x, right? So f prime of 4 times 0 by the chain rule. F prime of x times 1. So yeah, let's just make it negative. Another way you could look at this, if you remember your properties, I can make it negative and then just flip the limits. 4 to x, cosine of e to the t dt. That's all we're doing here. So properties can be helpful there. So that is the fundamental theorem of calculus weird. Okay? The weird fundamental theorem of calculus. We're still doing the fundamental theorem of calculus. We still just anti-derive it and plug in the limits. Then we just had to derive it again, right? So this is how I think of it. My mind goes through these steps. But I think the high school, I don't remember, but I think the high school version of me just said, oh wait, I'm anti-deriving it and I'm deriving it. I'm just right back where I started, right? And then I think high school me screwed up these, which is why I got a 4, not a 5 on the exam. So. Anyway. I tried to integrate things by hand that I couldn't integrate by hand. Okay, this right here, this problem right here is, in a strange way, just review. You have done everything on this already. It looks weird because I'm saying f is integral from 0 to x of g of t dt, where this is g. But you can totally do everything on here. Like down here, I'm asking you, at what point, if any, does f have a relative minimum? You're like, Mr. Kuhne, you gave me the graph of g, not the graph of f. How can I do that? And your eyes are about popping out of your head, aren't they? But I say, never fear, you got this. You got this. You get a problem like this, here's what I want you to do. And I can almost guarantee they're going to give you a problem like this. Okay? I can almost guarantee it. Because for the last like 6 or 7 years, they've had something like this. Okay? Purely theoretical problem. No word problem. No, oh, water's leaking out at this rate, or particles moving at this speed. No, this is it. This is it. Before you do anything else, here's what I want you to do. At the top of your paper, before you do anything else, you're going to do this. You're going to write f prime of x is equal to, what's the derivative of this integral from 0 to x? Not g prime, nope. f prime of x is equal to, okay, let's go through it. Ready? Well, if you anti-derive g, little g, we would call it like big G, right? Big G of x minus big G of 0. Okay, fine. I don't know what g is. But, yes. What's the derivative of big G? It's little g. F prime of x is g of x. Right? If I'm anti-deriving something, and then you want me to derive it, we're right back where we started, aren't we? So g of x. Then I want you to write underneath it, f prime, double prime of x is equal to g prime of x. Those are the two things you need. Once you have this, you have now just renamed this function, okay? So you can talk about f prime or g, it doesn't matter. But I'll just be talking about f prime, okay? This is going to allow you to do this, 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 and this so much more easily. Okay? First, though, let's start with this one. What is f of 3? Well, let's see here. F of 3 is, let me just go back to this original one, 0 to 3 g of t dt. So I don't have really a function to anti-derive here, do I? I just got to use the graph. But what is this asking me to find? The area under g of t from 0 to 3. Okay, so what is this area? How to find that area? Shout it out. Or just shout out the answer, either one. What is it? 4? The triangle, right? 1/2, 4 times 2. That's for that part. Then I've got a negative area, don't I? Minus 1/2, 2 times 1. And could you leave it like that? Sure, that's fine. But let's not. Three. Okay, now here's where it's like, what is f prime of 1? F prime of 1, you're like, well, I don't know. It didn't actually anti-derive it. How do you want me to derive what the area under 1? No, I don't want you to anti-derive the area under 1. F prime is equal to g. What is g of 1? Look on the graph. What is it? 2. That's it. It's 2. That's a lot easier, isn't it? What do you want? Tissues? I think I'm out, actually. If you go to the bathroom, you can. Sorry. All right, f double prime of 1. Okay, f double prime of 1 is just g prime of 1. What is g prime of 1? What does g prime find on g? It's the slope. The slope of g at 1 is -2. Do you see why I want you to put this at the top of your paper? It's going to make your life so much easier. Do this or you'll die. don't do this, well, you're gonna die. If you do it, you're gonna die anyway. So basically, you're gonna die, which is good because no one wants to live forever. Imagine how horrible that would be. Oh, I'm living forever. Oh, my friends. Bye. Yeah, you're dead. You're dead. Okay. Maybe make some new friends. Oh, now you're dead too. Okay. At what point, if any, does f have a relative minimum? Okay. When does f have a minimum? This is where you get out your when does it have a relative minimum? When f prime changes from negative to positive, right? At what point, if any, does f have a relative minimum? F prime changes from negative to positive at x equals now remember, when we're saying f prime, we're really talking about g. You don't have to put g because you already stated it up here. When does f prime change from negative to positive? Where? That goes from positive to negative. 7 from negative to positive at x equals 7. That's it. That's all you have to put. Now, AP readers are going to check. If you just say f prime, if you never mention this, then we're not going to give you the justification point. You have to make this connection. Okay? You have to make that connection somewhere. We read forwards. Okay? Now, if you have something down here, we're not going to use something down here to go back and give you points up here. So we read forwards. Okay? Now, if you put f prime equals g changes from negative to positive at x equals 7, that works. Okay? Or put it up here. I would just put it right at the top, though. Okay? F is concave down on what open intervals? Okay, concave down. Concave down is when f double prime of x is less than 0, right? When is f double prime of x less than 0? Also known as when is g prime of x less than 0? When is g prime of x less than 0 on this? Anybody? Stephen? 0 to 3. F is concave down on 0 to 3 because you've already made the connection up here. You can just write f double prime of x is less than 0. Now, there is actually something else you could put on here. You could also say because f prime of x is decreasing. Okay? That is something you can actually add to this over here. Concave up is when f double prime of x is greater than 0, or get out of this right here, f prime is increasing. Concave down when f double prime of x is less than 0, or when f prime is decreasing. And we can talk, if you want to do like second derivative tests right here, I can talk to you about how to do that, okay? What you would need to write for that. If you like second derivative tests, see me, let's talk about this, okay? Because there's certain ways you have to write it. Otherwise you don't get the point, okay? So, big thing is you have to make this connection between f and f prime is g and f double prime is g prime of x, etc. Okay. All right. I need just one question. One question you have over this or over this. Yeah.
What's the difference between the big A and little b?
Okay. This is, so you know, like f prime, if you integrate it, it becomes f. If they give you f and you antiderive, one way to show that is just call it big F. So essentially, the big G is the antiderivative of little g. Just like f is the antiderivative of f prime. It's just the notation that some people use. Okay. Good question. All right. There you go.